Namaskaram. Welcome back to my channel, Chemistry in a Nutshell. I have been talking about, the solid state, and while talking, I talked about, the constituent particles remaining in a very closely packed state. So when I tell closely packed state, one more terminology comes into play, that is called the lattice. So today, my topic of discussion will be lattice. So the question arises, what's a lattice? Now, lattice is a regular arrangement of constituent particles in a three-dimensional space. You can imagine this to be the lattice. Now, the constant particles may be, it may be atom. We already know that it may be an atom, it may be a molecule, it may be a ion. So whatever you take, you can imagine it to be in the form of a sphere, a ball. A ball is in the form of a sphere. And suppose if this is a sphere, you can imagine this to be a sphere in two dimension, and this is the center of the sphere. So also called, if you can imagine this to be in the form of an atom, so this is the nucleus of the atom. You can imagine it to be the nucleus of the atom. So this dot which I have given, encircled dot, this particular dot may be used to draw the lattice. So regular arrangement of constituent particles, let me go for the regular arrangement. So suppose these are the constituent particles. So you can see, I'll give one more layer of constituent particles, and you can see, interestingly, I've kept it in between the 2 points. Between the two atoms, I've kept one more atom. This is to keep it in a very tightly knit space. This will require less amount of space. You can imagine, if you have a box where I keep a layer of balls. Now next time if I want to insert more balls, so what do? I will be inserting a ball somewhere in the middle of the two balls which are kept. So here, you can imagine these are the constituent particles. Again, we can have a constituent particle. There's a third line which I am drawing out here. We can also have one more line out here. So you can see there is a regular arrangement of the constituent particles. It's regular, not irregular. Now, each of these points are called lattice points. So, the regular arrangement of the constituent particles in a three-dimensional space. In a three-dimensional space, how these particles are arranged, we are going to understand that concept. But before getting into that concept, let us first understand what is a unit cell. You see, the unit cell is the fundamental building block of a lattice. So, before getting deeper, let me define what a unit cell is. So you can imagine it to be the smallest 3D unit which can form lattice after repetition. The smallest 3D unit which can form lattice after repetition. You can imagine this to be a unit cell. A group of such unit cell can form an entire lattice. So you can imagine this to be a brick in a wall. Suppose you have this particular brick, I keep a brick before it, I keep a brick after it, I can carry on, producing such bricks one before the other, forming an entire wall. This wall, you can imagine it to be in the form of a lattice. When I'm carrying on with this video, you have to be more imaginative in this particular direction. So here we have a unit cell, and the unit cell is the smallest 3D unit. So you can imagine it to be in the form of a cube or cuboid. So what we are going to do is, let me draw the unit cell out here. So I can draw a line out here, I can draw a line out here. I'm just trying to form a cube. I've drawn a cube joining the dots. So this is a unit cell. You can have with a group of such 3D units. That means the smallest 3D unit, this is the smallest 3D unit which can form lattice after repetition. So I can repeat this entire process. So I can always show you this. Let me repeat this to form one more 3D unit. So this is one more 3D unit. So like that you can carry on, repeating this entire 3D unit to form an entire lattice. So this is what a unit cell is. So now we are going to learn about the different types of unit cell. Now there are 4 types of unit cell. There are certain textual content which first categorized into 2 groups, and the second group is again categorized into 3 groups. In any case, it's categorized into 4 groups. And then imagine it to be something like this: simple or primitive unit cell, and then we have centered unit cell. This centered unit cell is again categorized into 3 groups. That is face-centered, body-centered, and end-centered. So this is how the categories are built for the different types of unit cells. Now we are going to study about the number of atoms which are present in each of the different types of unit cells. So now we are going to discuss about number of atoms in different types of unit cell. So the first one obviously will be simple or primitive unit cell. So when I'm talking about unit cell, I'm talking about cubic unit cell. Before getting into the details about different units, here when I talk about cubic unit cells, that means the length, breadth and height of this particular unit cell is all equal. It's just in the form of cube. This, I believe you understand, this is a cuboid. In a cube, the length, breadth and height are all equal. You can imagine it to be something like that. Now here, I'm going to talk about the number of atoms which are present in simple or primitive unit cell. So here you have to understand this, that atoms are present in the corners of the unit cell. So if we have a cubic unit cell, let me draw it out here. Let me first draw a cube. Now what are the different corners? So this is one corner, this is a corner, 2, 3, third corner, fourth corner, fifth, sixth, seventh, eighth. So there are 8 corners to this particular cube. Now remember what I was talking about, each of these dots are actually the center point of the atom. So if that is the case, so that if you draw the entire sphere, the ball which I had talked earlier, So it will be something like this. The entire sphere will be, you can imagine it to be something like this. So number of corners is 8. And now we have to understand that how many atoms are really inside this particular unit cell. Now if you imagine this, if I draw a straight line over here, that means I'm dividing this entire wall or the sphere into two halves. I'm trying to draw it in the form of a 3-dimension. So here I've drawn this in 3-dimension. This is the line. This is the dotted line which I just drew. Now let me break this into half, and this part of the cube is inside this part of the cube. This part of the sphere is present. So the sphere is present, this much part. So you can imagine only this much part is inserted into the cube. You can imagine this to be. So here we can tell that 1/4 of the sphere, of the half sphere, is placed inside the cube. And if you take the entire sphere, so that means this is 1/8 part of the entire sphere. Out here you can understand it is 1/4 part. So you can, if you draw the cross section out here of the sphere, it is somewhat like this. Only this part is inserted. So only 1/4 of the sphere, of half the sphere is inserted into the cube. And if you take the entire sphere, that means 1/8 part of the sphere is inside the cube. So we have 8 corners representing 8 atoms with only 1/8 part inside the cube. So how much do we get? 1. So we can understand that from here, what do we understand? That in a simple or primitive unit cell, you have just 1 atom. Next, I'm going to talk about face-centered unit cell. Now, in a face-centered unit cell, atoms are present in the corner. Along with that, it is also present in the faces. So if we draw this, let me draw this unit cell, that is a cube, and we have the atoms in the corners as usual, like this. So we have 8 corners, and each of these corners have 1/8 part of the atom in it. So how many atoms do we get? 1. Now faces. If you imagine this, how many faces are there? 1, 2, 3, 4, 5, 6. So there are 6 faces. So in each of these faces, you have a atom inserted. So here is an atom. This is the top face. I have inserted an atom over here. I have inserted an atom over here. Behind, I'm going to add an atom out here. Below this, at the side of it, and before it. So here. So for 6 different sides, I have inserted an atom. So what part of the atom is inserted into the cube? Half of it. So there are 6 faces, and half of it is inserted, yielding, so how much do we get? 2, 3 is 6, so we have 3 atoms. So total 3 plus 1, there are 4 atoms in a face-centered unit cell. Now we are going to check out the number of atoms in the third type of unit cell, that is called the body-centered. body-centered unit cell. Now here, what do we have? We have atoms at the corner. As usual, the 8 corners. Along with that, we also have the body. Inside the cube, we are going to place an atom. So you can imagine it to be something like this. Let me draw a cube out here. So let me draw the atoms. So at the 8 corners, we have, as usual, the 8 atoms. So 8 corners, and we know that in each of the corners, 1/8 part of the atom is inserted. So we get one atom over here, and we are going to insert an atom inside, that means inside this cube. So let me draw it in a big way. So this, you can imagine it to be somewhere in the middle of the cube, inside. It's not bulging out from either of the faces or anywhere. It is inside. That means the entire atom is inside. So for the body, we have one entire atom. So total, how many atoms are there? 2 atoms are there. Simple, isn't it? And quite interesting, I believe. Next comes the fourth one, that is end-centered. End-centered unit cell. Here we have atoms at the corners as usual. Along with that, we also have it at the ends. Now let me represent that. So first of all, let me draw the entire cube. So at the 8 corners, we are going to have the atoms as usual. And we know that at each corner, 1/8 part of the atom is inserted. So we get one atom over here. And at the ends means you can take either of the opposite ends. Either you take this end at this end, or you may take this end at this end, or you may take this end or this end. That means opposite ends. You can imagine an atom to be inserted. So if I insert at the top and bottom, so here an atom and here an atom, that is at the top end and at the bottom end. So there are 2 faces to it. So 2 faces, and in each of this face, what part of the atom is inserted? Half of it is inserted. So how much do we get? 1. So 1 plus 1, there are 2 atoms to it. So 1 plus 1, there are 2 atoms to it. So that's it. That is how we find the total number of atoms in each of the unit cells.